Hello. So this is a multi-track conference, and there's an exciting talk about Nintendo and Xenix on the other stage. So if you're here for that, then you're in the wrong room. And Francesco just introduced me as coming from Copenhagen, and I usually start my conference talks with "Hi, I'm Martin. Me and my accent is from Copenhagen, Denmark, and now I'm living in London." So Tortoise evolved. I should start a timer. Actually, yeah. Tortoise evolved. I considered calling this talk Tortoise's Walking Pace, or Tortoise is not your application, but that might be a talk for a future time. So today's agenda is that I want to introduce to you what MQTT is, because it's not a common protocol. Not everybody knows it. And I want to introduce a client that I made called Tortoise. And I would like to discuss the API and how it will change to support the new MQTT specification, MQTT 5. So first, introduction. As Francesco said, it's a lightweight protocol, and it's used for machine-to-machine communication. So say we have these devices. We have a thermometer. We have a bus driving in the wild, posting data to the broker, and so we can see where our buses are. We can send commands to. We can use the protocol to send command as well. So we could send to the lamp that we wanted to turn on, and there's a wide range of applications. It's designed to be easy to implement on small constrained devices. So it works by having a centralized broker, and the devices on the network cannot see each other. The only way they can post messages to each other is by, like the kettle here, subscribing to the T topic, and the computer sends a message on the T topic. So let's look at the important concept called topics and topic filters. So here I've created an example with two famous buildings, and they both have thermometers on their floors. So both buildings has 3 floors, and they have a thermometer posting to a topic each. So let's look at that topic. So at an interval, our thermometer will post to, in this case, OCP tower floor 2 temperature. And it will publish a message called just 21. So the topics, they have a structure, and in this case, it's I decided to. My first level is OCP, like the building name, and the second level is the floor, and the third is the sensor type. And of course, you can build your own topics. Do what thou wilt. So we can reference them when we subscribe to something. We can do so by using topic filters. So here I use a literal, and it will, and this one will subscribe to this one topic alone. I can use single level topics. These are like pattern matches. So the plus match on one level. So in this case, if I write a topic field like this, we would get all the floors from the OCP tower of the temperature. And if I write like this, I will get all the sensors on the third level in both buildings, because I match on building and temperature sensors. We also have a concept of multi-level wildcards. They can only be on the last position of the topic filter. So this would match all the topics posted to the Nakatomi Plaza. The multi-level multi-level filter is mostly used for bridging to brokers. In general, it's best to match on a structure, because we will get a lot of messages from this. So A topic is used in a publish, in the context of a publish, when we send something out. And a topic filter is when we subscribe to something. That's an important distinction. Another important concept in the protocol is the quality of service. When we publish or subscribe, we can do so with quality of service 0, which means you receive the message at most once. Quality of service 1 at least once. And then the final one is quality of service 2, which tries to have a only once receival. So how does that work? For when our client sends to the broker with quality of service 0, we have no delivery guarantees. So this is there's no acknowledgement from the receiver, and this is kind of like a gen server cast. Mm-hmm. So for the quality of service 1, we in our message we assign a correlation ID, and for this in this exchange there's a PubSub, and the receiver will know that at least the broker received the message. If the sender sends the same message with the same ID after the PubSub, it will be considered new, fresh. So this is the reason at least once delivery. So to mitigate that, we got quality of service 2, where we have some guarantees of only receiving the message once by going. The client will send, kind of like before, it will send a message with a correlation ID, and then it will receive, the server will say, I received that. It's called a public. And at that point, the caller will know that it has received it, so it will stop sending the publish. It will respond back to the server that I see that you have seen the message, and then the receiver will say, cool, bro. So use the lowest level of quality of service you can get away with, because of course more protocol messages will go on the wire the higher you go. So for a client, you would need to implement the following commands. Like, we need to connect, and we need to be able to publish to the broker, and we need to, much better. We need to be able to subscribe, of course unsubscribe, and there's also a concept of ping. If we don't send anything to the broker in a long while, then we will have to say that we're still out there. And then there's a concept of disconnect, which will destroy the connection. And it sure would be nice if somebody had made a easy to use MQTT client, and somebody has, and that's me. It's an MQTT client with a nice logo. It's made by my friend Laszlo, and you should all follow him on Twitter. And I'm going to drink some water so you can pull out your phones and follow him. Great. So, what should a good client do? Like in my humble opinion, I think it should basically follow the specs. Like it should do everything that the spec allow you to do, and I as an author should not take any creative liberties to what I think the protocol should do. In other words, I should keep my opinions out of it, but I can provide good values. So, for instance, when we publish a message without a quality of service specified, I can just assume it's quality of service 0. And a good client should hide things that can be automated. So in other words, the client should hide the protocol details that can be hidden from the user without limiting the user in what they want to do. In other words, we should map Elixir semantics to MQTT semantics and figure out stuff that can happen behind the scenes. So in reality, we have two semantics we have to deal with. We have the concept of incoming messages, and we have outgoing messages. And these are, of course, different in the way we need to handle them. So first, let's talk about outgoing messages. So this concept is very familiar to us Elixir developers. These are two processes that are, like, one is sending a term to the other process. One interesting thing to notice here, I think, is that processes have identity, so we can reference them in the system. And of course, we send messages between processes by using message passing, and we have the send command directly in the kernel module, which is included in all Elixir contexts. So it's so fundamental to the language, like message passing. That's basically what we're all about. So, that is good. The concept here is that we have a resource that has an identity that we can reference and send messages to. So, in this handy diagram, I have a caller process. I have Tortoise. It's an application running in your Beam, and then we have a MQTT server running behind a TCP connection. So we want to send commands from our caller into Tortoise, and that needs to do the communication with the MQTT. And MQTT will send back an MQTT response, which Tortoise will handle and send back to us as an Elixir term. So the identity. For MQTT, there's a concept of a client ID. Every connection has this client ID assigned. So here I call it Toes, because I call my mascot Toes. Has nice toes. So the client ID is any UTF-8 string. For connecting, I've chosen to make a connection module, and I've chosen to make a start link function on it that will work as you expect. It will start a link connection. And I have written some documentation. I think it's the best part of the documentation about how, like, various strategies you can use to supervise your Tortoise connection. And of course, you can have multiple connections. They just need to have a unique ID. Basically, the MQTT server will kick the previous client off if you connect with an ID that already exists. So if you have two processes reconnecting with the same ID, you would have a loop of being kicked off and rejoining. It's fun. You should try it. So we pass in the client ID to the connection. Grayed out is server and handler, and basically this is the minimal code you need to write to get access to MQTT server without password or any authentication. And of course, this is running on the local host. So once we got the connection and we got the identity, it's pretty simple to send a message. We need to specify the topic as a binary, and we need to also send the payload as a binary. And here I specify that my 21 degrees is a float of 32 bits. And that is important for when you receive it. Again, you have to specify what the format that you receive, because this is a binary protocol. And I could have omitted the option list as the third argument here, because the default is a quality of service 0, but I can specify the quality of 0 or the service in options, like you would expect. So behind the scenes, how does that work? Like when we run our publish function in Tortoise, it will, with quality of service 0, we will request a network socket from the Tortoise application, which has an edge table. It will actually go directly to the edge table and fetch out this network socket. And that it will be given in the caller, and then we will shoot directly into the server. This is pretty neat because I basically save one message path there. It's much quicker to send a network socket to the caller and then have the caller send it directly into the MQTT server. Pretty neat trick. Any question? No. So I can unfortunately not do that for quality of service 1 because quality of for zeros we have no delivery guarantees. So the previous model was pretty good for that. For the quality of service 1, we need to store the message in the Tortoise application because we might need to resend it. So what I do is to create a reference in the caller, and then hold on to that, of course, and then send that reference into Tortoise along with the message, which will then perform the message exchange needed to fulfill quality of service 1. And as that is completed, I will get this back in my message box of the caller. For quality of service 2, it is the same semantics, same API. But let's look, like the message exchange, of course, is the quality of service 2. So let's look at the return message. We tag it with Tortoise, such that we don't collide with any other message. And we tag it also with the client ID and the reference for the that we just generated in the client. And then we have the third element, which is the return value. Here it's OK. So what we can do with that is to use it in a receive block. Or we can use it. We can pattern match on this pattern in a gen server, and we can use in gen server handle continue. So the public facing functions are the following. Like we have the start link that we looked at, which creates the identity, and then we have the Tortoise publish, which we also looked at. Then we have subscribe that takes 3 arguments, and the first one is the identity, and the second one is the topic filter we want to subscribe to, and then the third is options. And then we have similarly unsubscribe. And then we got the ping function. Actually, Tortoise will handle that automatically because you just need to send a ping message once in a while to keep the connection open. And then we got the disconnect, which will destroy the process and the instance. So that maps pretty well to the list I specified starting out. So handling incoming messages, this is the interesting part. So the observation here is that a connection has a life cycle, and we are familiar with other stuff that has a life cycle in our systems. Everyone familiar with the gen servers? No hands. So a gen server is basically an abstraction on a receive loop. So in this handy diagram, this is a state machine diagram, and this is a state that loops into itself. So it will do so until we hit the terminating state. The receive loop is where you handle the handle call, handle info, handle cast. So of course we got an init state as well, and this is our initial state. This should feel familiar to Elixir developers. So I have made my own behavior. And this is set out to do the same thing just for Tortoise. So what do we have? We have a receive loop where we handle our incoming pub-arc and subscription acknowledgements and incoming published messages. And of course, at some point, our connection will terminate. So we need to handle that as well. And then we got an initialization phase. And this is what we just saw with the Gen server. But the main difference is that we also have a connection phase, because when you initialize your connection, it will attempt to connect to the broker, and then it will go to the receive loop once that's completed. And dropping the connection is not necessarily the end of the world. We can reconnect in MQTT. If we reconnect with the same client ID, we can take over the previous session. So in that case, dropping the connection will just go back to the connection phase, and then we will get back to the receive loop. Actually, I should probably have had an arrow from connection to terminate as well. So the callbacks are as follows. We have the init, where we pass in the arguments, as you know, with a Gen server. And then we have a callback called connection, which has a status and a state. Oh yeah, the init, you can set a state for your internal, for your handler, where you can store data that you will use in your later callbacks. So the connection has a status and a state. And the status is up or down. And you can use that for your Nerves device, where you can flash a green LED when we are online, and a red one when the broker is offline. So we got subscription as well, which is fired when you successfully connect, or when you subscribe to a topic or unsubscribe from a topic. You'll get an up when you successfully subscribe to a topic, and down when you're successfully unsubscribed from a topic. And you'll get the topic filter that this relates to. And the handle message, which will handle the incoming messages. And then we got of course, the terminate, where you can reverse whatever you did in the init. So let's look at the handle message. I've written topic lists, and what do I mean by that? The thing is that if we received this as a binary, we couldn't on a reasonable manner pattern match on it. We need a better data structure to pattern match on. So I've decided to make it into a list of binaries, because as we see in the top, this is the MQTT topic, and this is what I ended up doing it for. A good data structure we can pattern match on. So this maps pretty well to MQTT semantics. Here I just ignore the flaw. But when you subscribe to a topic with a topic filter and you receive a message that matches that, you will get the data that was in that position, or what we're logging on. So here we would be able to say that even though we subscribe on all the floors, when the temperature sensor on the second floor will post to us, we'll get number 2 in that field. And a list is also, it maps pretty well to the multiple level topics. So this is an example where I pull out the building and the floor. Yeah, I think this is a pretty good interface for interfacing with the MQTT. So MQTT 5, let's hope that nothing changes that will change this interface. So what's new in MQTT? So now we got a concept of session exploration and the message exploration, and that relates to when you disconnect, when you drop from the broker, you can send a last will message, and the session exploration is what time duration should go from your getting dropped to the last will be dispatched, and now you can specify. Previously, it would just go instantly out. Message expiration, you can use that for saying that if the message is more than 20 milliseconds in flight, then just drop it. Then we got more verbose error messages, and that allows us to basically know the reason why we were kicked off the broker. And this will be really good for Tortoise, because then I can tell you exactly what happened. And then we got some capability negotiation on Connect. Again, now they can tell us that we're only allowed to send 32 kilobytes in a message. Previously, you could send, like, I think the maximum size is like 256 megabytes or something, which is pretty big for an MQTT message. And then we got there were some community patents, like formed in the community. So now they have been put into the specification. So RPC patents and shared subscription patents. And then we got enhanced authorization, pretty good. And then we got user-defined protocol properties, which is my favorite feature. And then you can go to the website and read all the new features. But how are we going to handle enhanced authentication? We need some changes to support that. And this is the previous state machine diagram I showed you from before. And we will basically have to add a new state, which happens as we're trying to connect. We can go into this auth phase where we can do a challenge response, and we can go back to auth as many times. It's like the broker can say, okay, give me more, and you can say to it, give me more, and at some point you will both agree that you are who you are, and then you can enter the receive loop. Previously we only had password and username password authentication. Of course that still works. So user properties. This is basically a way to extend the protocol with metadata on, and here I have a publish message, and I have decided to put some user properties in it, and it is a list of key value items. So they need to be a pair of UTF-8. So here I say that the scale is Celsius, and then I also say that my sensor ID has, I can basically tell the broker where I'm from, and this is pretty neat because the broker will just send these user-defined properties to the subscribing client without touching it. Just go through. It's a nice specified behavior. So I will need to change the handle message that we saw previously, because now there's more data than just the payload that we need to care about in the topic list. So I've decided to just expose my internal representation, because now you got all the data, and you can just say publish.payload if you want the payload, and you can say publish.properties if you're interested in them. So pretty neat. So it's not really a big deal, unless that they decided that these user-defined properties were such a great feature that they wanted to include them in all the protocol messages, which posed a problem, because if we observe the right-hand side of the screen here, the pubrec and pubrel and pubcomp, previously they only had an ID which correlated to the message that they correspond to. Now they can include properties as well. And the problem with that is that I set up some rules for myself, and the client should be allowed to do everything they want with the protocol, and I as an author should not take any decisions on your behalf of how you want to use the protocol. I should keep my opinions out of it, and I should hide things that can automatically be automated. Like I might think that the use-defined properties in the pub-rel is a weird thing because I cannot come up with any good use case for that. And I have asked around, and nobody seems to come up with a good use case for it. It's one of those things where I would say it's easy to add a feature, it's hard to remove it. So I have been yelling about this, but they went ahead with it. But I could go ahead and just say I don't want to expose the pub-rel to my end users because it's basically something that's just bookkeeping. Like, we're not really interested in it. So if I did that, I would be at odds with two of my my design goals here. So so let's take the challenge. So previously we had this interface, and we all liked it. We all thought it was great, but now I need to expose a couple of more callbacks to you. You can read. So at this point, Tortoise will become a lower level MQTT client that has all these callbacks. Most of them will be optional, but I will have to change some of the callbacks to allow you to add user-defined properties on the bookkeeping protocol messages before we dispatch them. I have to do it in multiple places because you have to be able to do it when you send a message and when you receive a message, and hence the many new callbacks. Handle auth is number 2 up there. That one will be called when we are in the enhanced authentication phase, and connection is still there. Init is still, as we are used to, terminate is there. I have decided to call what was previously handle message, handle publish. So, conclusion. Right now you can use Tortoise as in its 3.11 version, and it's in production in a couple of companies. SmartRent is one of them. And MQTT 5 will cause some changes to the API, just minor changes. And my work on the MQTT 5 is in a branch, and I work on it occasionally. It kind of works, but it still needs some time. And it will eventually be there. And Tortoise will drift towards a more low-level API to support everything. So this is the logo again, and this is the Twitter handle of the designer who made this logo. He makes awesome drawings, and if you want to have something good in your Twitter feed, you should definitely follow him. It's and he also retweet independent game developers. It's really a joy to follow him. Laszlo, and yeah, here's the GitHub.
I'll start with a question myself, and then I'll see if anyone else out here has questions. Are you able to actually provide the version of the MQTT protocol you want to use? Because you said there will be kind of non-backward compatible changes. Usually what you do is by saying, okay, I want to use this version, then you jump up and down based on what you need.
I have to backport that into the branch.
Okay.
Because the protocol messages has been extended with extra properties that is not understood by the 3.11 edition of the protocol. By the way, when the standard organization took over MQTT as a standard, they took it over in version 3. Then they made some changes and they called it 3.11, but in the protocol they called it 4. So they had to go to 5 for the next version. So it's not like I I sit on my hands for version 4.
All right. Any questions? Yeah.
Hi. I get this is a binary protocol. Do you think using Elixir protocols to enable the user to define message decoding will be a nice addition and something in line with mapping like language concepts to protocol concepts?
I'm not sure I understood the question, but you're like the payload is binary as well, so you can.
Yeah, sure. I mean, allowing users to define their own like data types, structs, and then using some kind of protocol to decode the binary into these structs.
Oh yeah, the next version of Tortoise will, like, I envision a world where people will build an interface on top of the more low-level Tortoise. So of course you could use structs there and encode and decode and have your own protocol implementations there, which would be pretty cool. I would like to see that. It's actually like, while it's I think the protocol has gotten worse in some cases, but I think it's also kind of exciting because once I get this out, people can try to experiment with their own APIs that builds on top of mine. So let's see how user-friendly we can get it.
Any other questions? Yeah.
Thank you for the presentation. In the middle, you said that Tortoise is handling some things for you, for instance, the ping command. I was wondering what else is it doing, like in terms of what's the supervision tree like, and how did you go about designing that?
The supervision tree in the new version is actually kind of shallow. So a connection has a main connection that accepts, like it connects to the broker having a TCP connection, and it handles incoming messages and dispatches to the callback functions. Then I have an in-flight process where I store the currently in route messages. And that's basically it for the next version, as far as I remember. What I handle in Tortoise is basically the bookkeeping, and for the next version, I just have to hook the user into the message flow, because I will basically have to ask the user, what do you think will happen next here? The previous version was like I could get away with 5 callbacks that didn't limit you in any way, because there was only one way to handle the bookkeeping. But yeah, the bookkeeping and the ping, I do auto ping for the user, and I ensure that the connection is up always.
So I guess my question was already answered in some way. So basically, when I'm using Tortoise, am I already at a level where I can just use it and it keeps the session alive for me? Mm-hmm. So, and I can just publish and subscribe and handle the responses, but all this stuff behind, I have to take care of. The session still being alive will be handled by Tortoise already.
It will keep the session alive, and if it drops, it will reconnect automatically.
Okay.
One last question. Yeah.
Uh-oh.
Uh-oh.
An easy one, what brokers do you recommend? There's obviously a few in Elixir and Erlang now.
There's a couple of brokers out there and implemented in Erlang, and they're really impressive, all of them. Like personally, I've worked most with VernMQ. It has some numbers where they have shown a cluster of 5 million connected devices. Both did that. The headphone company. And then there's one called EMQX, yeah, which also shows some impressive numbers. That one is from China. I think they say that they have 10 million connections on the broker. So it's it's fairly high scale.
I was actually corresponding with someone who was benchmarking both, and said that they're both really, really impressive. And I'm trying to convince them to come out and give a talk about it. So stay tuned. Okay, thank you. Let's hear it from Martin.
Thank you.